Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. So today I'm going to explain the topic DMA controllers 8257. So as this video is a part of series microprocessors and microcontrollers. Coming to the overview of today's presentation. So what is a DMA controller, why we are using DMA controller, and what is its architecture of a DMA controller, which we are discussing as here is a 8257 DMA controller, and what is the signal description or pin description of 8257, and how to interface a 8257 DMA controller with 8086 microprocessor. So coming to the introduction of a DMA controller. So what is a DMA controller? As the DMA stands for Direct Memory Access. Usually when we are using the systems or the CPUs, the processor which we are using, so if we want to transfer the data or if we want to retrieve the data from the memory, we will use the processor. So in some conditions, the processor doesn't require any operations. The processor doesn't do any operations on the data which we are accessing. So in that particular case, we can directly access the data from the memory to and fro the memory. So in such conditions, we will use this direct memory access. The peripheral which want to access the memory can directly approach the DMA controller, which is already interfaced with the 8086 microprocessor. So if the processor, if the peripheral device if this is the peripheral device, it needs to access the memory directly, but it is not possible because the memory will always be interfaced to the microprocessor. So if the peripheral device need to access the data in the memory, so there must be the processor. Actually, the processor will be there. So if the peripheral devices want to access the memory without helping the microprocessor, without having microprocessor, then we can interface this DMA controller. By using this DMA controller, the peripheral device approaches DMA controller that it want to access the data from the memory. So what DMA controller will do, if the peripheral devices request, so it is considered as a D request, if the peripheral device requests DMA controller that it needs to access the memory. So what the DMA controller will do, before directly giving the permission to the peripheral device, the DMA controller requests microprocessor to hold the address, data and status bus, all the bus interface. So to hold the bus interface, it will reach the microprocessor. Now if the microprocessor gives the acknowledgement to the DMA controller, yes, you can take the buses, I have hold the buses, so I am not doing any operations using the buses. Then the DMA send acknowledgement signal to the peripheral device that actually it can access the memory directly without the involvement of microprocessor. So this is the basic concept under a DMA controller. So how to send the request signals, how the peripheral device will access the acknowledgement given from the microprocessor. So based upon, there are two conditions in 8086 microprocessor. Two conditions in microprocessor, that is one slave mode, master single processor, and minimum mode and maximum mode. So minimum mode and maximum mode. To send the request in minimum mode, we will use HLD and HLDA, hold and hold acknowledgement pins. So the DMA controller will send hold signal to the microprocessor. If the microprocessor gives the permission to access the bus interfacing then it will send hold acknowledgement back to the DMA controller. If the processor is in the maximum state, maximum mode, then there is a request and grant pins. So the DMA controller will request the microprocessor that it needs the access of a bus interface. So then the processor will get back to the DMA controller by using the grant as an acknowledgement pin. So this is how the minimum and maximum mode pins will be worked in DMA control. interfacing DMA controller with 8086 microprocessor. Now coming to the master and slave mode. While we are using anything, like if we want to transfer data from directly using CPU or our 8086 processor. So now in this particular condition, the 8086 is in the master mode. So it is having the whole authority over the every bus using any peripheral devices. But if the other peripheral devices wants to access the data from the memory, so now in this particular condition, the DMA request, as I already told you, if the processor give access to the DMA controller, that the other peripheral device can access the memory directly without using microprocessor. In such condition, the microprocessor will be in the slave mode and the peripheral device which is accessing the memory, actual memory directly without a processor, that will be in the master condition. So usually, normally the 8086 is the whole authority which is acting as a master in this particular case. But while peripheral devices approaches the DMA and DMA approaches the 8086 microprocessor, if 8086 microprocessor give the controls over to the DMA, then now in that particular case of conditions, the peripheral devices which actually accessing the memory to and fro memory, that will be in the master mode. At that particular time, the 8086 microprocessor will be slave mode. This is how it will work. Next, coming to the internal architecture of 8257 DMA controller. Basically, to interface the DMA controller, we need to know what are the blocks having the DMA controller and what are the pins there in a DMA controller chip. So here we are using Intel's 8257 DMA controller, which will be easy to interface peripheral devices up to 4 peripheral devices. In this particular DMA controller, there are 4 channels, so you can access 4 peripheral devices can actually approach the processor to access the memory. So, but at particular time only one channel can be accessing the memory. So it totally depends upon the priority resolver which is having in the DMA controller. So in this particular DMA controller 8257, there are 4 channels. Each channel is having 2 registers, 2 16-bit registers. One is address register and another one is counter register. Here why I have mentioned it as a 14-bit register means the lower 14-bit count register will actually having the count, and the 15th, the remaining 2 bits decides which operation will be performed, like whether it is reading the memory or whether it is getting the memory out. So there are 2, each channel is having 2 16-bit registers. One is address register and another one is the count register. And apart from this, there are other 2 registers. Total registers are 10 in 8257 8257 DMA controller. So each channel having 2 registers. So we are having 4 channels over 8 registers will be there, which is of 16-bit registers. And another register is mode set register and another one is status register. So totally 8257 is having 10 registers. So to access these 10 registers, we are using A0 to A3 address lines. Here we are actually having 8-bit address lines, and here in particular the lower order address lines A0 to A3 will be accessing these 10 registers based upon their address. So and each channel can transfer data up to 64 kilobytes of data can be transferred using each channel. So you can say that each channel can address 64 KB of memory, either read or write. So each channel can be programmed independently. So you can independently program the address lines over each channels, and you can independently program the count register, counters in that particular channel. And each channel can perform read transfer, write transfer and verify transfer operations also. It generates mark signals. What is mark signal means? You can say that every 128th byte of data transfer, there will be a mark signal. So it will, once the mark signal got high, we can know that this is the 128th memory byte will transferring the data. So this is all about the introduction of 8257. So this is the block diagram of 8257. As I already told you, there will be 4 channels. This is the channel 0, channel 1, channel 2, channel 3, and each one is having 16-bit address register, count register. Here also 16-bit address register, count register. And as I already told you that if any external peripheral devices want to access the memory, so it will reach the DMA controller. So where it will request. So if this is the peripheral one, it will request the DMA controller by using this DRQ. So it's a request signal getting from the peripheral devices to the DMA controller. So if the microprocessor grant the request and it holds the bus data and it gives the permission to the peripheral devices, then that acknowledgement signal will be given back from the DMA controller to the peripheral device. So de-acknowledge, DACK0 is the channel 0th acknowledgement signal getting from the microprocessor by using DMA controller to the peripheral devices. So you can access these 4 channels, but at a time you can access only one channel. So which channel will get accessed first? If there is 2 peripheral devices requesting data from the memory by using this same DMA channel, same DMA controller by using 2 different channels like CH0 and CH1. Channel 0 and channel 1 is requesting the data. So which channel will get first option to get the peripheral device to connect it to the memory? So it totally depends upon the priority resolver. Most of the cases channel 0 will have in the highest priority likewise. So this priority resolver will solve the problem. So which channel need to access, which channel requested first, or which channel need to get the urgent information, like that this priority resolver will solve this issue. So coming to the other part of the 8257, there are 3 main blocks in the 8257 microcontroller. The first one is data bus transfer, which is used to transfer the data. To write the memory or read the memory, that data should be transferred using the DMA controller. That's why here D0 to D7 is a data lines which transfer the actual data. And there will be read and write logic. Here input IOR is input output read data. IOW is input output write data. Clock signal to simultaneously work this all. Reset, if we are resetting the DMA controller, all the registers, internal register will get back to its original forms. So as I already told you, these 4 A0 to A3 address lines are used to fetch the registers. Total 10 registers are there. These 10 registers will be addressed by using this A0 to A3 lines. And coming to the CS is a chip select line. So to enable this particular 8257, there will be one chip select line. So CS is the chip select line. As you all know that it is a negative logic. So if we give 0, then only 8257 will be in the enabled condition. If we give 1, it will be in the disabled condition. Coming to the other one, to access whether to write the data or read the data from that particular address location. So if I want to access the data through using the channel 0, so where would I find the address of that particular channel or address of that particular memory? So here, as I already told you, that 16-bit address register which is using in this particular channel will hold the starting address of the memory block which the peripheral device need to access. So if we want to access the memory, the peripheral device want to access the memory, there is one condition that the 2 registers which is having in this particular channel should be containing the valid information. That the first one, address register, will hold the 16-bit address to access it is the starting address of the location. So the address register, 16-bit address register, will be having the valid information. And then the control register. So this control register actually holds the decimal equivalent number of DMA cycles. How many cycles does this operation performs? So that DMA cycles equivalent decimal number should be in this 14 to A0. So if we consider this is a C0 to C14. So these 14 bits will be the equivalent decimal number of DMA cycles, and the other 2 bits will represent here A0 to A14 and A15. C14 and C15. These two bits will signifies whether there is write operation is being done or read operation is being done. So these, if the DMA controller, each particular channel is having these two valid information, then only actual data will be getting transferred or received. So here another one is there, which is control logic and mode set register, in which channel is performing the operation, or which address location has been fetched by the DMA controller, or which operation being done. If the memory read operation is done, if the memory write operation done, everything will be controlled by using this one. Here the HRQ and HLDA. So after getting the request from the peripheral devices, actually the DMA controller need to ask the processor. So it need to give the request to the processor. So HRQ is the request generated by a DMA controller to the processor. If the processor gives the acknowledgement signal, that would be the HLDA, hold acknowledgement signal received from the processor to the DMA controller. So now after receiving these two signals, then the memory read operation or write operation will be performed. Then the next one is AEN, address enable, whether to select address or whether to select data. It will always depends upon AEN. So next one is address strobe lines. The address strobe lines will be there. And TC count, terminal count. So this is what, if the TC count is getting 0, then all the DMA cycles already been done. So the data operations will be done after the end of the counter register. So mark is, as I already told you, mark is, it will generate the signal from 128th byte. It will say give the status that 128th byte of the data has been transferred. So every mark signal, so we can say that 128th byte of the data is transferred. This is the internal architecture of 8257 DMA controller. So this is the pin description. As every pin I have already explained in the block diagram itself. So these are the address pins. This is terminal count pin, and these are the lower byte address pins. VCC power supply. So D0 to D4 using this D5 to D7. These are data lines. These are address lines. This is terminal count. These are acknowledgement signals of 4 channels. Four channels. So these are request signals generated by the channels to the DMA controller. Peripheral devices, actually peripheral devices request these using this DRQ, and the acknowledgement from the DMA controller will be given by these 4 acknowledgement signals. And HLDA in HRQ, hold request, and HLDA, hold request will be generated by the DMA controller to the processor, and hold acknowledgement will be getting from the processor to the controller. Ready. This is the mark, memory read and write operation, input output read and write operations. So this is address enable, address strobe, CS is a chip select, clock, reset signals. So these are the pin description of 8257 DMA controller. So the next one is, as I already told you. So the next one is how to interface a 8257 with 8086. This is the basic block diagram to interfacing a 8257 DMA controller to 8086 microprocessor. So first it will start from here. Here A is address bus, data bus and control bus. Totally we can say that it is a system bus. So first of all, the peripheral devices request the DMA controller to access the memory. So it will send the request signal using DRQ. So if then whenever DMA controller is getting the request signal from the peripheral device, then it will send HLD signal to the CPU, or you can say that it is a 8086 microprocessor. It will send the hold. So I want to access some other peripheral devices, want to access the memory. So you need to hold your system bus. So if the 8086 will give the acknowledgement by using HLDA, yes, you can access the peripheral devices, can access the system bus as I am holding the system bus. Usually the system bus will be connected directly to the memory bus, memory devices. So it will hold the signals, it will hold the data transmitting. So now the DMA controller will give the acknowledgement. DMA controller will give the acknowledgement to the peripheral device that using DACK signal. So now the peripheral devices can actually access the memory without having the 8086 involvement. So as in this particular case, the peripheral devices which accessing the memory is in the master mode, and now 8086 will be in the slave mode. So it doesn't do anything, just hold the system bus. So peripheral devices which want the access the memory can access the memory by using DMA controller. This is the interfacing diagram of 8257 with 8086 microprocessor. So until now I have discussed what is a DMA controller, and particularly the Intel's family 8257 DMA controller, and what is the architecture and block diagram of 8257, what is the pin description of 8257 microcontroller, 8257 DMA controller, and how to interface DMA controller with the 8086 microprocessor. Thank you.